Chapter 11, Section 6 in the 7th grade note-taking guide is entitled Probability of Independent and Dependent Events. So what are independent and dependent events? What are we talking about? Independent events are events for which the outcome of one event does not affect the probability of the other. Meanwhile, dependent events are events for which the outcome of the first event affects the outcome of the second. So what we're talking about here are two things we can find the probability of. In the first situation, independent events, all right, you've got two things that do not affect the probability of the other. So they could be, for instance, two totally unrelated events. For instance, if I was talking about flipping a coin and rolling a die, because those two things don't have anything to do with each other, they would be independent events. Let's say I was picking bingo balls, and I took a bingo ball out, and I looked at it, and I said, hey, it says B6. And then I put B6 back in the hopper and pulled again, which really wouldn't be the way you'd play, but it's a good example. All right, if I put B6 back in and then pulled again, because everything was still in there the second time that was in there the first time, the probability has not changed of me picking any certain number from the first draw to the second draw. So that would describe independent events. On the flip side, if I were to go in and reach in and pull out B6, and then I were to take B6 and put it aside and then pull again, now all of a sudden I've changed the scenario and it describes dependent events. Why does it describe dependent events? Well, when I started off, there was 75 numbers in the bag. When I got to pull 2, because B6 had been pulled out, there's only 74 numbers in the bag. Well, if probability is comparing to the total, which it is, that means there's one less option in there for me the second go around, which means the total has changed, which means the probability has changed. And that's why it's a dependent event. What I did the first time impacts what I can do the second time. So let's take a look at what they're talking about here in 1A. Decide whether each set of events are dependent or independent and explain. Kathy draws a 4 from a set of cards numbered 1 through 10 and rolls a 2 on a number cube. Well, the question really is, does me pulling a card from a set of cards and rolling a number cube have anything to do with each other? No, those are unrelated events. Doesn't matter what I pull from the cards, it's not going to affect how I roll the number cube. What I roll on the number cube doesn't affect what I can pull on the cards. So here, the outcome of drawing the card does not affect the outcome of rolling the cube, so the events are independent. So now in number 2, they want us to find the probability of choosing a green marble at random from a bag containing 5 green and 10 white marbles, and then flipping a coin and getting tails. Alright, so again, we're describing independent events here. How do I know they're independent? Well, the question is, does me flipping a coin and me picking a marble have anything to do with each other? No. Either way I look at it, those two things don't have anything to do with each other. So, let's talk about probabilities here. What's the probability of me making both these things happen now? Well, as you can see, what they've done is they've listed the probability of me picking a green marble and the probability of me picking tails. Probability of me picking a green marble, well, there's 5 green marbles out of, if we do some simple adding, 15 total marbles. So the probability of me picking green is 5 out of 15. Now you'll notice here they didn't write 5 out of 15. The reason they didn't write 5 out of 15 is because they reduced the fraction. They reduced 5 over 15 down to a third. Then we're talking about me flipping a coin and getting tails. Probability of me getting tails is 1 out of 2. That one doesn't have to be reduced. There's one winning scenario there. Tails out of 2 total scenarios. That's where the fraction 1 out of 2 came from. To find the combined probabilities, we simply multiply as we've defined it in an earlier section. So I'm going to multiply together a third and a half, and when I multiply those together, I get 1 out of 6. Remember, we just multiply straight across the numerators and the denominators. So the probability of me choosing a green marble and a coin landing on tails is 1 out of 6. In other words, if I tried this 6 times, 1 out of those 6 times, theoretically, I should be able to pull green and land on tails. All right, let's go ahead and take a look here at number 3. Number 3 says a reading list contains 5 historical books and 3 science fiction books. What is the probability that Juan will randomly choose a historical book for his first report and a science fiction book for his second? So, as far as the probability of him choosing a historical book, which is where they're going to start, probability of him choosing a historical book is 5 out of 8. Why? There are 5 historical books in the collection, and total, what we get when we add up all the books that are listed here, there's 8 books there. So that's a 5 out of 8 chance of me finding a historical book. Science fiction book, well, there's 3 science fiction books. But now, as you can see, the bottom number has changed to 7. Why has it changed to 7? Well, remember, we've already pulled up here in number 1 a historical book. So if I've already pulled the historical book out, there's now 1 less total book to choose from, which means the probability has changed, which is why up here in this first line, they're talking about these being dependent events. They're dependent events because I'm changing the total number of possibilities. If I change the total number of possibilities, I've changed the probability. So it's 3 out of 7 now. So to find the combined probabilities, I'm going to multiply together 5 out of 8 and 3 out of 7, as you can see. When I multiply together 5 out of 8 and 3 out of 7, those combine to make 15 over 56. All right, let's go ahead and take a look at the check it out examples here. Decide whether the study events are dependent or independent and explain. Annabelle chooses a blue marble from a set of 3, each of different colors, and then Louise chooses a second marble from the remaining 2 marbles. Well, it's kind of a giveaway what they're saying here, but they're saying here that Annabelle starts off with 3, and then when Louise gets to draw, there's only 2 left. So what happened the first time? There were 3 marbles. Did it impact what happened the second time? Yes, it did, because there's only 2 marbles. When it impacts what happens the second time, that describes dependent events. Find the probability of choosing a red marble at random from a bag containing 5 red and 5 white marbles, and then flipping a coin and getting heads. So, if we're talking about the probability of me choosing a red marble at random from a bag containing 5 red and 5 white marbles, here the probability would be 5 out of 10. Why? There's 5 red marbles and 10 total marbles. Now, of course, we can reduce that. That's going to reduce to 1 out of 2. Then I'm also supposed to flip a coin and get heads. They want to find the combined probabilities. Well, combined probability here, we're going to multiply, but I need the fraction for flipping a coin. Well, chance of getting heads, there's 2 heads, or 2 options on the coin, and one of those is heads. So the probability of me getting heads is 1 out of 2. So I got a 1 out of 2 chance of getting the red marble and 1 out of 2 chance of getting heads on the coin. When I multiply these together, that's a 1 out of 4 chance of me pulling red and flipping a coin and landing heads.